Okay, so here's a problem from the book, 318. If you use Mastering Engineering, you might get slightly different values, but I think the strategy will be the same. So we can use all of our techniques, method of sections, method of joints. I think it's going to be important to get started to probably find the reactions first. That seems like a reasonable beginning. Oh, I should start off saying, do you see any zero force member situations here? I do not now. Would you say AB?
AB. Oh wait, no. I guess you could.
No, the only one I see possibly would be C because it's 2, but it has a force there, so that disqualifies it. And everything else with the 3 forces or more.
Okay, well, with AB, isn't there? I get point A.
Now AB, we may find out that AB is 0, but it is not a by inspection 0 force member with the 2 cases that we talked about.
I was just wondering, you're saying from the 2 cases. I was going to say, if you just look at A, there's no reaction force in the X direction.
That seems reasonable. When we do method of joints at A, you'll find, there's only an AY reaction, so you'll find probably that AB is going to be 0. But that's harder to do by inspection, because by inspection, with the multiple cases we do have 2 elements connected together, but there is a load. So by definition, they're both not 0. But in this particular case, AB will probably be 0. That's a good observation. So I'm going to go ahead and do that first, find your reactions. So I have AY at the roller, and over here at C, we've got CY and CX. I don't know if I see any advantage to summing moments at A or B. Do you guys see any advantage? No, not really. Maybe. No, I don't really see any advantage. So I'll just sum forces at C because it's a pin. No other reason. And we'll make sure it's in equilibrium. Oh, hang on. So about C, I'm going to have 1, 2, 3 applied forces creating moment and a reaction. Let's do all the applied forces first. The 8 kilonewton, does that create positive or negative moment with my sign convention? Positive. So that's 8 kilonewtons, and the moment arm looks like it's 3 meters. What about the 6 kilonewton force, positive or negative? Negative. So that's 6 kilonewtons, and it's going to have a moment arm of also 3 meters. And then finally, this 6 kilonewton force acting down is going to be positive or negative? Positive. And it'll have a moment arm of, looks like 6 meters. Does that look good so far? So we've taken care of the 3 applied forces. Let's look at the one reaction. AY, is that going to create positive or negative moment? Negative. And that will have a moment arm of also 6 meters. So AY will be 13? I'm guessing. No, I did that wrong. That would be 10. I'm guessing too. You guys get 10? You got what? 7? Oh well. It was a guess, right? Alright, now I'll sum forces in the Y direction, since I have AY. I'll assume up is positive. So the way I've drawn it here, I've got AY acting up, and there's CY also acting up. Now look at all my forces acting down. I've got 1 8 kilonewton force at B and 1 at E. And that's it. So I should be able to find CY What's that? 7? That's interesting. I wouldn't have expected that, but it is what it is. And then we'll sum forces in the x direction. This one will be pretty easy to do. I'll assume to the right is positive. In this case, I have Cx to the right and 6 also to the right. So it looks like Cx is actually to the left, negative 6 kilonewtons. Okay. So we have our reactions, so now we're going to have to go for our bar forces. We've got 1, 2, 3, 4, 5, 6. We've got 7 more things to find. So now we can talk a little bit about strategy. Looking at the external parts of the truss, probably around the supports, would be a good place to think about doing method of joints. We already discussed earlier, joint A is going to be a good place to start. Because AB will be all horizontal, AE will be all vertical. That should be an easy place to find both of those, so we get those two. We could also come over here and do a joint at C. And again, you'll see that CD is the only one of the two forces that has a vertical component, so we could write one equation, one unknown, and then find that. So that would knock those two out, and we would just be left with this internal set. Does that sound okay? Good place to start. So let's start with joint at A. So there's my free body diagram. I'm going to assume my forces are always in tension. Well, I'll assume they're in tension. So there's AB, and there's AE, and then AY we found was 7. I think that's it. So if we sum forces in the y direction, assuming up is positive, I've got the force in AE acting up and my reaction force also acting up. So it looks like my force in AE is negative 7 kilonewtons. So that's compression. That looks reasonable. With these forces here at the top, there's a force pushing down. It's not. It doesn't seem unreasonable that would be in compression. And then, as you guys noticed before, if I sum forces in the x direction, and if I assume to the right is positive, all I have is the force in AB. So that's a pretty easy one to solve. It's 0. So 2 down, 5 to go. So I'll go ahead and come up here and I'll put a little mark in them. We've got those two. Oh, wrong ones. This one and this one. These are the two we're going to next. So that'll be joint at C. Does this seem familiar when you guys were working on it last night? Is so far so good? Yes, Mr. Ryan. Oh, it asked just for 3? Oh, yeah, mine is too. I didn't pay attention to that. Well, let me mark those off with a different color here. So the book wanted ED, BD, BD, and BC. Huh. Okay. I'll tell you what I'm going to do. I'm going to finish this because I wrote joint C, and then I'm going to go back and work that problem. Okay? Is that the one that was in the book? I mean, that's what's on Mastering Engineering? Okay, I misread it. I'm sorry. So let's finish this one real quick. Actually, the problem in the book is easier. The one I'm doing is harder because it's got more work to do. Let's see. So this is the force in BC. and this is the force in CD, and then my reactions at C. CY was up 7 kilonewtons. And CX, I assume to the right, but it's negative, so that means it's actually in this direction. Oh, 6, not 7. That's a 6. Doesn't look like a 6, but that's what it is. And while we're there, I'll go ahead and try to figure out the geometry of this force. Well, it looks like it's 3 to 3, so that's a slope of 1 to 1. So let's start by summing forces in the y direction. We'll assume up is positive. In that case, I'll have the y component of CD, which is 1 over the hypotenuse, which is square root of 2. And that'll be the force in CD acting up. And also I have the force, reaction force acting up. So it looks like the force in CD is negative, and whatever 7 times the square root of 2 is, 9.8? Is that it?
Yeah. So in that particular case, how would you not do 3 over square root of 2? I mean, I know it's a 45, 90 triangle.
Well, the other way to do it would be it's actually 3 to 3.
Yeah.
So that would be, you would have to have 3 squared plus 3 squared, which is 18. So it'd be 3 over the square root of 18, which is the same as 1 over the square root of 2.
Maybe that's not good.
So I lost track of the number. What was the number again? 9.9? 9.9? So we could finish this by summing forces in the x direction. In this case, we have BC going to the left, so that's negative. And we have CD going to the left, that's negative. And we also want the horizontal component, so again, that's 1 over square root of 2. And then we have this 6 kip force, also, 6 kilonewton force. So a little more complicated, but what's BC equal to? We have to put this negative 9.8 in here, so that would be 13? That's a big guess. No, I did that wrong. It should be 1. Huh? 1? Positive 1? Okay. Now that we've done that, which is kind of off in the wrong direction, if the original problem, as stated, was just looking for these 3 bar forces, you could cut that section and now look at a free body diagram on the left side or a free body diagram of the right side and do method of sections. You guys have a preference? I think the right side has less going on. So now, if I did that, and we come down here and I'll just write method of sections, I'll redraw that right-hand side. So I'll start with D. So from D, I'm going to assume a tension force in FBD and a tension force in FDE. Let's see, what else do I have? This would be the force in BC, and then I've got the is that it? I think that's it. Oh, then the reaction forces, right? So CY is up 7 kilonewtons, and CX is to the left 6 kilonewtons. How's that look? I think that's it. So using our strategy for method of sections, are there some points in this plane of the free body diagram where some of our unknowns are concurrent? Yeah, there's two obvious ones. There's D, D, E, B, D. So D is going to be one of them. Is there another place? Yeah, we got BD and BC. I don't know, there doesn't look like a B there. Even though it's so, if you project the line of action of these forces, you would see that they would be concurrent at B. And I think that's going to be it for finding those. The other thing to notice is conveniently that BD is the only force that has a vertical component. So I should be able to sum forces in the y direction and get that, and not worry about what DE is or BC. So since you guys said D first, that's the one we'll do first. So let's sum moments about D and make sure everything's in equilibrium. So about D, the force DE and the force BD create no moment, but the force BC does. And what kind of moment would that create? Negative. And its moment arm would be the height of the truss, which is 3 meters. What else do we have? The two applied forces. The 7 kip creates positive moment. I'm sorry, I keep saying kip. The 7 kilonewton force creates positive moment with a moment arm of 3. And the 6 kilonewton force creates negative moment with a moment arm of 3. Everything has a moment arm of 3. That's convenient. So we should be able to find that the force in BC is, all the 3's cancel, that goes to the other side. It looks like 1. Is that right? It came out positive, so that's a force that's in tension. Now we can go in some moments about B. So now we're down here, about B. So about B, of course BC and BD create no moment, but DE does. So what kind of moment is it, positive or negative? About B. With right-hand rule, it's positive. And with the moment arm of 3, the height of the truss. Now, through B, this horizontal force passes through, so it creates no moment, but the Y force does, and it also creates positive moment, and has a moment arm of 3. So what's the force DE equal to? Looks like -7. So far, so good? On the Mastering Engineering, were one of these forces variable and 2 were constant, or were they all different? You guys remember?
The 2 are the same and the 1 was different.
Okay. And then the last one would be to sum forces in the y direction. Make sure that's equilibrium. If we look at the y components, only the force in BD has 1, so we'll say minus because it's going down. And the other y forces are +7 going up. So it looks like the force in BD is 7. Well, computationally, this was pretty easy. I mean, it was kind of lucky. Everything had moment arms of 7. That made it kind of nice. I think that problem in the book has answers. Let me check the answers. Let's hope we got them right. So give me a second to flip them back. If you guys, those of you who have the book, will know that if your problem is not starred, then it has an answer in the back of the book. So 318 says, let's see, it says that FBD is 7 kilonewtons in tension, so we got that right. It says that BC is 1 kilonewton in tension, and we got that right. And it says that ED, or I wrote it DE, is 7 kilonewtons in compression. So we got that right. That's good. It's always nice when I get it right. So now that we see it all, what was the difficulty? What was the problem? Do you guys have any? You see it more clearly now, or you have some questions? That was one of my strategies for working the original problem when I said all the bars. I was thinking about cutting a section here to help me find this top and this diagonal very quickly. Because with method of joints, we'd already found these two, and with C, we'd found these two. So what we were missing was this top piece, this diagonal, and this piece. So we could actually make a vertical cut here and find those two very quickly, and then we could do a lot of other things here. We could actually do a cut here and just sum forces in the y direction. So one thing we should talk about quickly is, if you do a method of sections, you could do it just to go after one or two forces. You don't have to think about it being, you have to get all of them. Right? You can even cut through a section where 4 unknowns are there, but if you have one of them from a previous result, you just include it. It's not as clean as cutting a section with 3 unknowns and writing 3 independent equations like this. But it's a possible solution strategy. Yes?
Okay, so if you were doing the method of joint at joint D, and you're taking some of the x components, do you have to have a D, C of x, or you just leave it on?
You want to do a method of joints at D?
Like if you were to, would you have to do like the x component at D?
Well, there'd be if you sum forces in x direction, DE would have an x component, and CD would have an x component.
Right.
So if you didn't have one of those already, you'd have one equation and 2 unknowns. And the same thing would happen if you went vertical, right? This one would have a vertical component and that one, so you'd write one equation and 2 unknowns. So you got to know something going to D. Remember, method of joints just gives you 2 equations. And right now at D, we would have 1, 2, 3 unknowns. So that wouldn't be a good place to start. But if we did a joint at C and then we had CD, then we could go here at D and do it.
I would have to include the x component and do sections at D.
Where would you cut your section?
I mean, like the one you did at the bottom.
Right.
Isn't there an x component at D?
No, I didn't cut through DE.
Oh.
Or DC. Right? I only cut through 3 of them. So see, this one's still intact.
Oh.
So my cut only went through this on this purple line. So I only have to worry about the bar forces in those 3 elements.
So with method of sections, do you have to be able to draw a straight line through all the...
Straight line? Not necessarily a straight line.
I was just wondering, so... I mean, obviously, I know you might not have the...
to be honest, I could do a method of sections and just cut that joint D out.
Yeah, that's what I was about to say.
But look what happens. They're all concurrent at D. So I'm not really going to get 3 independent equations. Right? One of my equations is already satisfied directly. So that's not going to help me. You're going to find out if I try method of sections at D, I wouldn't be able to solve for it.
I just wonder, like, if...
Unless you went some weird point out in space, and then you're going to get simultaneous equations, and it won't be as clean. See, one of our strategies, remember, is if we're a computer and we don't care, then we just go to every joint, write our 2 equations, sum them all up, solve them simultaneously. You probably don't want to do that as a human. It's a little more challenging, especially on the exam. So your strategy is to apply method of joints, or method of sections in such a way that you're always just generating, hopefully, one equation and one unknown, or at most two equations and two unknowns. And kind of take it apart and work your way through it. So it becomes problem specific in kind of how you apply it, but these are the tools that you have. So get comfortable with them and kind of learn how to apply them. To be honest, 318, the way it was posed in the book, all you would have to do is, after you found your reactions, is just this. This is the solution. Right? Because it only wanted these three forces. So I misread it and was not only doing those three, I was solving for the remaining, I think there's 7 total. So I was getting the other 4. So any other questions about this? This is a reasonable test problem, by the way, I think, for method of sections. Maybe not for all the forces in the... That's a little tedious. It might take a little longer than you need.
Do we have an idea when the first test is going to be?
I'll probably schedule it for a day that it'll snow. That's usually what happens.
Sounds good.
But usually it's around... I like to do it before spring break.
So sometime late this month or